So what was the last topic that we did in the last class? The last topic that we did, huh?
Simple microscope when the image is at infinity.
Okay, so we have finished simple microscope. The next is the compound microscope. Fine. So if you know simple microscope, then compound microscope is something which is very easy. Anyways, what were the two? What? Just tell me few things, huh? Then we can start with the compound microscope. Hishma, Minashi, all were not in the last classes. Nazia was there. Nazia, what does angular magnification means
It is the ratio of angle subtended by image and angle subtended by the object
on the eye, right?
on the eye.
Yeah. So when those who were absent in the last class, in microscope or in optical instrument, we are doing the second last part of the ray optic. We're just about to finish this chapter. In this topic, optical instrument, we have to study certain optical instrument like microscope and telescope. In all optical instruments, we measure the angular magnification. Angular magnification means the ratio of height of image and height of object. We don't measure linear magnification. We measure angular magnification. While measuring angular magnification, we came across two cases. In the first case, your final image is at least distance. Least distance would mean 25 centimeter from the eye. And the next case is when your final image is at infinity. These are the two cases that you can consider for a microscope, simple or compound. So we have finished a simple microscope in the last class. We'll do a compound microscope. See, there are certain limitations with a simple microscope. Using a simple microscope, you can magnify your image, but there's certain limitation. You can magnify your image 10 times, 20 times, but not more than that. If you want to magnify your image more than 1,000 times, then you need something else, and that is the compound microscope. So compound microscope is just an optical device. It's used to magnify image of tiny objects. It can magnify up to 1,000 times. So how we do this, like how we magnify the image of an object up to 1,000 times. To do this in compound microscope, we use two lenses. One is the objective lens and another is the eye lens. So objective lens is the lens which is placed near the object, which you want to magnify. That object could be your cell. You in a biology lab, you are trying to see the organelles of the cell. So object could be your cell, the organelles of the cell. So this is the lens, objective lens, which is placed near the object. Then there is another is the eye lens. Eye lens is the lens which is placed near the eye. So near the eye, the lens which is placed is the eye lens. So both in the compound microscope, both objective and eye lens have small focal length. But if you compare objective and eye lens, then the size and the focal length of eye lens is slightly greater than the object. I'm repeating again, both objective and eye lens are of short focal length. But if you compare objective lens and eye lens, then the size of the eye lens is slightly greater than that of the objective lens. We'll see why it is so. Okay, so that is the compound microscope. Please note it down, then we'll start with the ray diagram. Please note it down, write it fast. Can I scroll it further?
Yes,
One
sir.
minute, sir.
Please tell me once you have written.
Yes, sir, done.
Okay. So everyone
Sir,
have,
could
yeah,
you scroll to the objective part?
yes. Gautam Krishna, Hishma, Minashi, Saifullah, you all were absent in the last class, no?
No.
You were there, Saifullah.
Yes.
Okay. So those who were absent, did you went through the recordings of the last class? Krishna,
Yes, sir.
Minashi, you were absent for the last 2 weeks, I believe, huh?
No, sir, just 1 week.
Just 1 week. Okay. Did you went through the recordings of the class?
The first class I saw.
First class. Did you went through the recording of last class? That's the optical instrument one? No.
No, sir.
Krishna, you?
No, sir.
See, if you miss class due to any reason, just please go through the recordings. You can do that, listen that recording at 1.5 times, increasing the speed. Because usually, when the lecture depends upon the previous lecture. So I'll try to make it as simple as possible, but still some of the topics will depends on the previous lecture. And these derivations are super important. I believe you all have written up to here, no? Let's start with the calculations. Noha, Naziha, uh, Nabil, Akshay, written?
Yes, sir.
Yes, sir.
Yes, sir. Sir, what is that, sir? By using rack and
Pinion, Pinion. Basically, you can just change the separation between the two tubes, between the objective and the eyelets. Rack and pinion. These lenses are arranged at the two end of the tube. So by adjusting the length of the tube, you can change the separation between the two lenses.
yes, sir.
Okay, so let's see if I can explain using this ray diagram only. If you have any issue in understanding this ray diagram, then I can draw another ray diagram. That won't be an issue. So this is the case when final image is at least distance of distinct region. See, in compound microscope, we use two lenses. So whenever we use two lenses, there is one common approach. The image of first lens will act as an object for the another. So whenever we have two lenses, we will use a common approach. The image of first lens will behave like an object for the second lens. So this is your first lens, huh? This is your first lens, this one. So this first lens is known as objective lens. This is the focus of objective. We place our object AB beyond the focus of objective. This is object of the objective lens. And this is the objective lens. So this separation here is the object distance. So let's repeat it again. This is the objective lens. This is the object for the objective lens, and the distance between them is object distance for objective lens. So we will see will be the image of this objective lens. So two rays we will use for the image formation. One is parallel to principal axis, another is passing through the optical center. So this is the first ray, this is the second ray. These two rays are meeting over this point, and this is your image, A prime, B prime. So this A prime, B prime is the image for your objective lens. For objective lens, this V naught is the image distance. This is the image distance. And this is for the objective lens. For objective lens, AB is object. Sorry. Yeah. For objective lens, AB is object and A prime, B prime is image. Is it clear for everyone?
Yes.
Yes, sir.
Okay,
Yes, sir.
let me reconfirm once. Anshika, for the objective, what is the image for the objective? Anshika, you can use chat room also if you are facing issues with your mic. So, yeah. Krishna, what is the image for the objective lens? O dash. Anshika, O dash is this is the optical center. I'm asking about the image of objective lens. This is the objective lens. This AB is the object for objective lens. What is the image for objective lens, Anshika? Okay. Krishna, what is the image for, yes, A dash. Yes, yes, you're right. Krishna, what is the image for the objective lens? Okay. Hishma, what is the
A
image
dash,
for
B dash.
A dash, B dash is the image for the objective lens. Now, this image of the objective lens will act as an object for eye lens. This is your eye lens. This is the eye lens. So this A prime, B prime is image for objective and this is object for eye lens. So we will set the separation between the two lenses in a way that this image, A prime, B prime, image for objective and object for eye lens comes between the focus of the eye lens and the optical center of the eye lens. This FE here is the focus for eye lens. This is the focus for eye lens. So this image here, image of objective lens and the object for eye lens, that is A prime, B prime, comes in between the optical center and the focus. And for a convex lens, if an object is placed between the focus and the optical center, then the image will form a virtual and erect and a magnified image. So this is the object for eye lens. One ray will pass through the optical center. This will go straight. This is the second ray. It will diverge. So these two rays will not meet in the forward direction, but when you reproduce these rays in the backward direction, they appear to meet at a point. And this is the A double prime, B double prime. So this is the final image, A double prime, B double prime. And this A double prime, B double prime is the image for eye lens. So let's discuss object and image of eye lens again. This is the eye lens. This here, this larger lens is the eye lens. A prime, B prime is the object for eye lens, which is at a distance UE. A double prime, B double prime is the image for eye lens, which is at a distance D. This is distance of closest approach, least distance of distribution. So this is the case that we are discussing. No, the final image is at least distance of distribution. Means your final image is at a distance D from your eye lens. This is D. So this is your final image. For magnification, we need object also. So for placing object means you will remove the simple compound microscope. You will remove the lens. So you just have eye, naked eye. So in the place of eye lens, you have your eye. And you place your object at a distance D from the eye. This object is AB is the object for your eye. So you want to compare the magnification of an instrument. So if you want to compare the magnification of an instrument, what you will do, you will first look at the object without the instrument, and then you will look at the object with the instrument. So this AB is, you are looking at the object without the instrument. So without instrument, it's AB. With instrument, it's A double prime, B double prime. Is it clear, this ray diagram now?
Sir, this is compound microscope.
Yeah, that's compound microscope, first case of compound microscope. Ishma, Krishna, Sakina, Yashika, is it clear?
Yes, sir.
Yes, sir.
And also to solve numericals of the compound microscope, this ray diagram should be very, very clear, because the good numericals will modify this thing. You have to use ray lens formula multiple times in good numericals of compound microscope. So the ray diagram would be very clear. In ray diagram, two things should be clear. Where is the object for objective and the image for objective? The object for eye lens and the image of eye lens. These two things should be very, very clear for the ray diagram. Okay, do it. Draw this ray diagram and then we start the calculations. Calculations are quite easy. If you know ray diagram, then calculations are.
सर आज लिखना है ऐसे स्टार्ट करना
हाँ, yes. थोड़ा सा था पहले कभी ये सब मिस हुआ है, but you can take screenshot later on. This is the calculation वाला part. While drawing the ray diagram, if you want your diagram to be correct in the first attempt, just first draw the ray which is passing through the optical center. You can modify this ray later on. First draw the ray which is passing through the optical center. Similarly here, first draw the ray which is passing through the optical center.
Sir, for B prime, that ray is not coming from anywhere.
Sorry, this from B
B
prime.
For B prime prime, the B dash dash.
Yeah, can you please repeat your question again?
So for A double dash, the ray is coming from O2, right, sir?
The ray
Or-
is coming from O2 and these two rays. These two rays are meeting over this point.
Yes, sir.
And you're asking which ray is meeting for B
Yes, sir.
prime prime. This ray which is passing through the optical center. You pass a ray through the optical center. Okay. So this is one ray. This is the ray which is passing through. So this point on the principal axis is your B. Basically, the point that we take on the principal axis means the ray is passing through the principal axis. So the ray which is passing along the principal axis will go without any refraction. It's going straight. This ray is going straight. You want another ray to cross over this point to make the image, right?
Yes, sir.
You can take one more. Yeah. See, one ray is passing straight. This ray is passing straight. The another ray could be There are various possibilities. We usually don't draw these rays. Just draw the ray diagram. I'll show you. We don't draw the
Which
rays.
is angle alpha in this diagram?
Angle alpha is nothing. It is beta.
This is beta, right? There should be also angle alpha.
Yeah, there is alpha. That is in the next diagram of this.
Okay, sir.
Alpha will come. I will just draw the ray diagram. I will show you how to get this point B double prime. Please tell me once you all have drawn this diagram. Minashi, Ishma, done?
Yes, sir.
Anshika, Akshay,
Yes, sir.
Uneep?
Yes.
Sure. Okay, fine. If you all have drawn this diagram. So Nabil is asking to get the image of a point, at least two rays should coincide. So see Nabil, the first ray is passing through the principal axis. Huh? This is first ray which is passing through the principal axis. The first ray which is passing through principal axis is actually passing through the optical center of the lens, and this will go straight without any deviation. The another ray is, you can incident another ray here. Huh? So this ray will diverge. So this and this ray, they will diverge. So if you produce them in the backward direction, they appear to meet at some point. So, but just to make the ray diagram simpler, we don't draw this ray. The rays will come from B also, na? So there are various rays which are coming from B. You can see like this is the ray which is coming from B. It gets diverged. This and this ray will get diverged. So when you produce these two rays in the backward direction, they appear to meet at a point, which is your B double prime. Yes, Nabil, is it clear now?
Yes, sir. Sir, could you just zoom out a bit?
Yes. But just to keep this ray diagram simple, there's already too many rays in this ray diagram. Usually authors don't show these rays, but there are these rays also. And just one more thing, this thing like this A double prime, B double prime could be in between these two lenses or it could be beyond these lenses. That doesn't matter. So if you check 4 or 5 authors, you will take this A double prime, B double prime in between the two lenses. You will take beyond the lens. That really doesn't matter. So it just depends how much is the distance between the lenses. If distance between the lenses is more than 25 centimeters, then your image will be in between the lenses. But if the distance is less than 25 centimeters, then your image will be beyond the objective lens. Your image will be somewhere. Okay, fine. So let's draw this diagram also. So this is your eye. This is your object AB. And this distance is T. That's it. So this is the actual size of the object that you are watching. This is the actual size of the object that you can view. This is the size of the image. See, now what we are supposed to calculate here. Here we have to calculate the angular magnification, which is the ratio of angle subtended by image and object on the eye. So this is your object AB. This is subtending some angle alpha on the eye. So this is your angle alpha subtended by the object. Then this is your image A double prime, B double prime. This is subtending some angle beta on the eye. So the ratio of beta and alpha is the magnifying power, ratio of angle subtended by image and object on the eye. But the condition is both your object and image should be at 25 centimeter. So see, this is your object, this is at 25 centimeter. This is your image at A double prime, B double prime. This is also at 25 centimeter from the eye, this T. So just need the ratio of beta and alpha. Now, to calculate alpha and beta, the calculations are very, very easy. See, so let's first get the value of beta. For beta, you can use this triangle A prime, B prime, O2. This is the triangle A prime, B prime, O2. Anshika, what is tan beta in this A prime, B prime, O2? Tan beta, just tell me the name of the sides which can make tan beta.
Bn upon b dash o2.
Tan beta will be perpendicular upon base. Huh? So that will be A prime B prime divided by O to B prime. This is tan beta. I'm taking tan beta from A prime B prime O2. So we can say that tan beta is beta A prime B prime O to B prime. Similarly, we can take this alpha. So for alpha, we'll be using this triangle ABO2. ABO2. So Krishna, what is tan alpha in this triangle? Just tell me the ratio of the sides. Nothing else. Gautam,
Sir,
Krish.
AB by yes, AB by D.
D, or you can say this is O2B, right? AB by O2B is it. So when we take this ratio, tan beta is A prime B prime by O2B prime, AB by O2B prime. This is beta, this is beta, this is alpha. This comes out to be the equation of beta. This comes out to be the equation of alpha. I just substitute it here. So this is A prime B prime by O2B prime. So I should write these steps here. These steps will confuse you. So M is beta. What is beta? Beta is A prime B prime divided by O2B prime divided by alpha. Alpha is AB divided by O2. You can write this as like you can take this term in the numerator. Na? So it will be A prime B prime divided by O2B prime multiplied by its O2B divided by AB. So that's it. You can do one more thing, like you can write this A prime B prime divided by ABC. What is A prime B prime by AB? If you look at this ray diagram, this A prime B prime is the height of the image of objective lens. And what is AB? It's the height of the object of objective lens. So what is the ratio of height of image and height of object? Is there any specific name for this term? Ratio of height of image and height of object?
Magnification.
That's the magnification. So this is the image for objective lens. This is the object for objective lens. So this is magnification for objective lens. And Nabil, what is the formula for magnification? We have studied this in lenses. What is the formula for the magnification of objective lens?
Sir, it is V by U.
V by U.
HI by HO or V by U.
Yeah, V by U. So V is the object distance for the objective lens and U naught is the, sorry, V is the image distance for the objective lens and U is the object distance. See here your object U naught is negative. See, light is going to the right and you are going from O2 to B, you're going to the left hand side. So U naught is negative. So let's call this as equation number 4. Let's call this as equation number 5. We need more things. We need O2B. O2B we need. Minashi, what is O2B in this diagram? Like this O2B. What is O2B? Just tell me with the proper sign.
Yes, sir. Negative U.
No,
D.
no, that's D. That's D.
D.
So O2B is minus D. Then what is O2B prime? This is O2B prime. O2B prime. What is O2B prime here, Munib?
Sir, object distance from eyepiece to base.
Object distance. So island. So UE. Yeah? Positive UE. So your O2B prime is UE. It will be plus UE or it will be minus UE?
Negative.
Minus UE. So you can write that O2B prime is minus of UE. So if you put all these values here, like this one again, let's call this as equation number 6. No, 6 is called, we call this as 6 and 7. So if I call this as equation number 6 and I call this as equation number 7 and I substitute all these values here. So instead of this A prime B prime by AB, I can write V naught by minus of U naught, right? And instead of this O2B, I can write minus D. Instead of O2B prime, I can write minus of U. Minus minus gets cancelled out. So you have minus of V naught by U naught into D by U. So there is one small problem with this expression. The problem is this UE. We'll try somehow to convert this UE in terms of focal length and the formula for least distance. So next we will repeat the calculations that we did in the simple microscope. If you can remember this calculation, it's simple microscope also. Okay, I have to go back. Yeah, we repeat this thing now. This was the formula for simple microscope. We replace this U with 1 by D plus F, 1 plus D by F. We'll repeat the same calculations here also. So here what we will do is we will use the lens formula here. For the simple microscope, let's use the lens formula. So 1 by UE is what? It's 1 by V minus 1 by U is 1 by F. So you can say, let's write the entire lens formula. 1 by VE minus 1 by UE is 1 by FE. Now, if I substitute all values with the proper sign convention, what is VE for the eye lens? It's minus T. UE is negative, so I can write this as 1 by UE, which is 1 by FE. Or I can write 1 by UE is 1 by FE plus 1 by T. And I call this as equation number 9. So I can substitute this 9 here. Instead of 1 by UE, I can write 1 by FE plus 1 by T. So this D, I just substitute the value of 1 by UE, 1 by FE plus 1 by T. If you multiply it here, and if I multiply it here, this is D by FE plus D by D. D by D is 1. So I get M is minus V naught by U naught, 1 plus D by FE. And see, this is capital M. This is the magnification or the magnifying power of the compound microscope. What is V naught by U naught? That is M naught. What is M naught? M naught is magnification of objective. This is the magnification of objective. What is ME? That's magnification for islands. This is magnification for islands. So see, the total magnification is the product of magnification of individual lenses. This is what we have discussed while doing combination of lenses also. If you have 2-3 lenses in combination, then I wrote that total magnification is the product of individual magnification. And I tell you at that time also that we are not deriving it here, but we will do this in optical instrument. So this is the point where we derive this expression, that a total magnification is always the product of individual magnification if you have more than one lens. And this product doesn't depend whether the lenses are placed in contact or they are at some separation. The magnification is always the multiplication of magnification of individual lenses. There's one more small thing, that is length of the tube. See this L here, this means the length of the tube. So what does length of the tube means? Length of the tube simply means the separation between the objective lens and the eye lens. So here, this is the objective lens. This is the eye lens. The separation between these two lenses is what we call the length of the tube. So we can write length of the tube as this objective distance, the image distance for the objective lens, and this is the object distance for the eye lens. So when you add V naught and UE, you get this thing, the length of the tube, mod of V naught plus mod of V. We are putting mod here. The reason is L is not an optical length. L is just the separation. It can't be negative. It's just the separation between two lenses. So we don't use sign convention. Another important thing, it is not a general formula. So no need to consider sign convention. So when you use this relation in a numerical, no need to consider any sign. So when you are using this formula, it's not a general formula. It's a particular formula which is valid for compound microscope only. This is valid for a particular case of compound microscope. So no need to consider sign, just use this relation. Please note it down.
Sir, could you show the upper diagram? Yes, ma'am.
This one. See, if you can understand this simple the compound microscope, the first case, the second case is straightforward. Just have to slightly change the position of the object. That's
So can you explain about
it. Sorry.
length of the tube?
Length of the tube is just the separation between the objective lens and the eye lens. That's it. The separation between this objective lens and this eye lens is known as the length of the tube. There's nothing in it. Which is, see, from here to here. The distance is V naught, and from here to here, distance is UE. So L is just the sum of V naught. Okay, just the distance between two lenses, nothing else.
So this is common for all the cases.
No, it will vary from case to case. But length of tube is the distance for objective and eye lens for all the cases. But in some cases, it will be V naught plus UE. In other case, it will be V naught plus FE. So it can keeps on varying. In that sense, it can vary. Can I scroll it now?
So this should yes. None, sir.
Okay. So, okay, you're right. Yes, written.
None, sir.
Sure. So next is you can use one approximation here. Like the approximation is if your object AB is very close to the focus of objective. Means this is the focus of objective, and this is the object for objective. So there could be an approximation where this object AB is very close to the focus of objective.
Sir, can you show the last part of the equation?
Yeah, this one.
Yes, sir. Yes, tell me.
Sure. Tell me when you have written, then I will explain.
None, sir.
Okay. The next is the approximation that this object AB, you can take this object AB to be very close to the focus. So if this object AB is very close to the focus of objective, that means your object distance is equal to F naught. And this is your image distance. This image A prime B prime. The next approximation is this image is very, very close to the islands. So if this A prime B prime, which is image for the objective, is very close to the islands, then you can say that V naught is approximately equal to L. So you can use these two approximations like U naught is equal to F naught and V naught equal to L. So here, instead of V naught, you can write L. Instead of U naught, you can write F naught. And this is the final answer. Just note it down, then we'll do the second case.
Done, sir.
Next, देखिए, the second case when your final image is at infinity. See, this is the islands which is making the final image. So this is the object for the islands. This is the islands which is making the final image. So a lens can make an image at infinity if the object is placed at its focus. So if this A prime B prime is placed at the focus of the islands, then this islands will make image at the infinity. So this is how we will proceed. So the only change in the ray diagram is this object AB of the objective lens, the same place. This is the image A prime B prime for the objective lens. This is at the same place also. We just shift the separation between the objective lens and eye lens in a way that this image A prime B prime comes at the focus of the eye lens. You know that final image will be obtained by the eye lens. So you place the object of the eye lens at the focus. So when the object is at the focus, the rays will passing through the lens will become parallel and the final image will obtain at infinity. So a slight difference in the derivation that instead of Fe, see here, your object is in between optical center of the eye lens and the focus of the eye lens. But now your object is exactly at the focus. So when your object is exactly at the focus, your final image will be at infinity. This is the ray diagram. And again, the modification in calculation is also the same. Instead of UE, we'll just write FE and everything will remain same. Just note it down, draw the ray diagram, then we'll start the calculations. Just first write the this definition. If you know one case of an instrument, then another is very easy. Like you just have to put A prime, B prime at the focus of the eye lens. That's it. In the mathematical part also, instead of UE, you will write FE. That's it. And we'll go. Can I scroll? Please draw the ray diagram. Don't take screenshot of this diagram. Huh? Draw the ray diagram. It's very easy. It's the same as the previous one. Just A prime B prime is at the focus of the islands, and the rays will become parallel. That's the only difference. The rest of the calculation is also same. It's just small modification. Instead of UE, we will write FE. And that's it. So these derivations are very important for your final exams. These are five. Usually from ray optics, the 5 marker questions are either from Lensmaker formula, spherical refracting surface, or from the optical instruments. Usually.
Sir,
Yes.
sir, 7th May is the official date for NEET.
7th May is the official date, yes. Nabil, are you going to attempt this January one? This January attempt of JEE?
Sir, I don't think so, sir, because
Is there any test
practical
center in
process.
Saudi? Is there any test center in Saudi, or the test center is in India only?
Can you repeat, sir? I can't hear you.
Sorry,
Sir, could you repeat, sir? I couldn't hear you.
I'm asking the test center for JEE. Is there any center in Saudi, or the centers are in India only?
Sir, I think there's one in Riyadh.
There is.
Yes, sir, I think.
There is one in Saudi.
Yeah, sir.
Then you should give that attempt. Please don't skip that attempt. You have 2 attempts now, one in January and another is in April. And it's not just for Nabir, it's for everyone else. If don't skip any attempt, huh? Do that give that attempt of January also. It will give you an idea. And I don't think it will it should match with any of the exam. It will not even match with your pre-board exams. Your school will take care of it so that
No, sir,
yours
we have practicals during January.
okay.
Completion.
Can I scroll it if you have drawn this ray diagram? Akshay, Anshika, Arpit.
Government.
Yes.
The rest of the calculation is straightforward. There is no change in the second diagram. This is eye. You place an object at a distance d from the eye, and this is making an angle alpha. Even the name of the triangle will remain same. Everything will remain same except this UE. Instead of UE, you write minus of F. That's it. Tell me once you have written. I will just scroll down. We'll do telescope also. First, we will finish all derivations. All derivations are just of the same pattern. Then we'll do the numericals and optical instrument. Can I scroll it? Okay. So see, if you check this derivation, the beta by alpha, everything is same. There's no change anywhere except this step. Instead of UE, you can write this as minus of FE. So this will be the final expression. That's it. You don't have to use lens formula also. The derivation will end here. Everything is same. Just please note it down first. There's nothing that I could explain. The same steps, everything is same. There's just minor change. Instead of UE, you have minus of it. Please note it down. We'll start telescope, we'll finish telescope, and then we'll come to numericals. Akshay, are you applying for J?
Not yet, sir. Not sure.
Why?
Like I also practicals during January 17th January.
Okay, but center is in Saudi only, na?
Yes, sir, but it will be like very far. Like
They
Jeddah
said
or
it's still Riyadh, sir.
Riyadh, Jeddah. I'm in Alasa. It's like 300 400 kilometer far away from.
So we'll concentrate on April attempt. See, during you can give only just 2 attempts of JE, basically 4 attempts of JE. One while you are in class 12 and another when you take a draw. There's no third attempt. Tell me once you have written, we'll start the telescope. We'll do numericals after finishing telescope. Written, everyone?
1 minute, sir.
Can I scroll it now? Tell me once you all have written. We'll start telescope. Then we'll come to numericals. Yes, written. Can I scroll it now?
Yes.
Sure. We'll do this numerical. It's a very lengthy numerical. Do it later, but right now we'll concentrate on telescope. See, what is telescope? Telescope is comparative easy. We have two types of telescope. One is astronomical telescope, which we use to view astronomical objects. Another is terrestrial telescope, which we call binocular. So binocular is not a part of syllabus. Astronomical telescope can be further divided into two types. It could be refracting. Refracting means we use two lenses, or it could be reflecting, where we use one lens and one mirror. So in most of the observatories, the type of telescope that we use is the reflecting type telescope, the one which have mirror. Or refractive again can be divided into two categories: the one when the final image is at infinity, and the one when your final image is at least distance of distribution. This case in NCRT is referred as normal adjustment also. This case is normal adjustment also. This is the normal adjustment. So this is the normal adjustment, and this is when your final image is at least distance. Just note it down, then we'll start with the cases. Please note it fast. Telescope is comparative easy than a compound microscope. Although telescope also have two lenses, but the calculation part is comparative. So the case when the final image is at infinity is known as the normal adjustment. NCRT have discussed only the normal adjustment, but there is one numerical in the NCRT which use this case of final image at least distance also. Will do both the cases. Everything, huh? So astronomical telescope, we are doing refracting type telescope. It's used to view astronomical objects. It consists of two lenses. One is objective, and another is eye lens. The objective lens is a lens having very large aperture, means in some cases it could be in meters, and a very large focal length. So this is a conceptual question: why we take the aperture of objective lens to be very large for a telescope? The reason is, in telescope, your object is a very, very large distance. And is the light from the object which is entering into your instrument. So the more the amount of light that can enter into your instrument, the better would be the intensity of the image. So we take a very, very large lens so that the maximum amount of light can enter into your instrument. So that's why we call that we take the aperture to be very large. And then is eyepiece. Eyepiece is the lens which is connected, which is near the eyes, and it's a small lens having smaller aperture. The reason is the light which is coming from the lens should enter your eye. If the lens is very large, then most of the light will get wasted. It won't enter your eye. You can see only that image which the light from which can enter into your eye. So we keep it to be small. So there are two cases. One is when final image is at least distance. This case have a lengthy calculation, and the another is when your final image is at infinity. So first note it down, and then we will start with the first case, that is when your final image is at least distance. We'll try to finish it today. So if we can finish it today, most probably in the next class, we can finish with the ray optics. The rest of the topics are very small, like photoelectric effect and all those things are very small topics.
Sir, can you scroll up, please?
So can we start the calculations? Nabil, Akshay, Alia.
Sir, can you
Ashwin.
scroll up, please?
This is a conceptual question. Huh? This one is the concept. This is the conceptual question. Why the aperture of objective is very large? The reason is so that maximum amount of light can enter into it and your image is very bright. Okay, now let's discuss case one of the telescope. When your final image is at infinity. See, for a telescope, your object is at infinity. When your object is at infinity, that means rays are parallel. So the parallel rays are coming for an object at infinity. Where does parallel rays converge, Akshita? Anshika, sorry. Anshika, where does parallel rays converge? Alia, where does parallel rays converge? Yeah, at the focus. Huh? So parallel rays converge at the focus. So this is your objective lens, a lens having a very large aperture. So parallel rays are coming from infinity or astronomical object, maybe moon. So these parallel rays will converge at the focus, and this is the focus of your objective. So for objective lens, your object is at infinity, and your image is at the focus of the objective, which is A prime, B prime. So this is image for objective lens. That's the first diffraction. The second diffraction will be through this eye lens. For eye lens, this A prime, B prime is your object. So the image of the objective lens will act as an object for eye lens. So this A prime, B prime is the object for eye lens. And again, one ray will go straight without any deviation, another will diverge. So when you reproduce them in the backward direction, you will get this image A double prime, B double prime. So for objective lens, your object is at infinity and your image is at focus. So image distance for objective lens is f naught and the object distance is infinite. For your eye lens, this A prime, B prime is the object and this A double prime, B double prime, this one is the image. The object distance is UE, which is less than the focal length of eye lens, and the image distance is at D, because this is the case where you need your final image at D distance. V is equal to D. So you can say this is image for objective lens and object for eye lens, or this is the image for eye lens. Now see, what is magnification is always the angle subtended by image and object on the eye. But the problem is your object is at infinity. So what we do is we take the angle subtended by the object at the objective. So this is the angle alpha, which the rays coming from an object is making with the principal axis. So this is the angle which is subtended by your object, which is at infinity on the objective lens. If this is alpha, then this is also alpha because these are vertically opposite angles. And this beta is the angle which your image, which is A double prime, B double prime, is subtending at the eye, which is beta. So magnification is just the ratio of these two angles, beta by alpha. Now there will be one issue. When we write the formula, the definition of the magnifying power, we'll write angle subtended by image and object on the eye. Your image is subtending an angle on the eye, but your object is not subtending this angle alpha on the eye. Object is subtending this angle alpha on the objective lens. So here we'll use an approximation. We say, see, this astronomical objects are very, very far away. So as compared to the distance of astronomical object from the objective lens, the distance between the objective lens and eye lens is very small. So it doesn't matter whether you take angle with respect to the objective lens or you take angle with respect to eye lens, the same thing. So alpha you can take with respect to objective lens, or you can take this with respect to eye lens also. So instead of taking alpha with the eye lens, we take with the objective lens. This will make our calculations easier. So this is what all authors do. They write angle with respect to eye lens, but they take angle with the with respect to objective lens. Draw the ray diagram and then we'll start the calculations, easy calculation.
Sir, can you scroll a little bit for a minute? Yes, sir, done.
Saifullah, Gautam, Minashi, can I scroll it if you're done with the ray diagram?
1 minute, sir.
Krishna, any issue with the ray diagram?
No, sir.
Minashi?
No, sir.
Krishna, what is the object of islands here?
A dash B dash.
And where is the object for the objective?
It's coming from infinity.
It's coming from it. Krishna, you also have PCM combination of physics, chemistry, and maths.
No, sir, not math.
You don't have maths. tell me once you are done with the ray diagram, start the calculation.
Done, sir.
Okay. See again, magnification is the ratio of beta and alpha. For beta, we'll be using this triangle O2 B prime A prime. So we can write tan beta is approximately equal to beta, which is A prime B prime by O2 B prime. Similarly, for alpha, we'll be using this triangle O1 B prime A prime. So tan alpha is alpha, which is B prime A prime by O1 B prime. So this is tan beta. This is tan alpha. If you take ratio, see both the triangles have A prime B prime. So A prime B prime will get cancelled out. It's O1 B prime by O2 B prime only. And see what is O1 B prime? O1 B prime, that's V naught or equal to F naught. So O1 B prime is F naught. What is O2 B prime? O2 here and B prime here. It's minus of UE. It's object distance for islands. When you substitute these things here, it's F naught by minus of U. The next task is to somehow convert this 1 by UE in terms of D and FE. So again, using lens formula. So U is minus of UE, V is minus D. So when you do these calculations, you get 1 by U is 1 by FE plus 1 by D. So the same thing that we have done in simple microscope, then with the compound microscope, we're repeating the same step with the telescope also. So when you put these values here, so minus of F naught, 1 by FE plus 1 by D is minus of F naught by FE1 plus FE by D. I'm taking this FE as common, so that's 1 plus FE will go to numerator, FE plus D. That's the magnification. And the length of the tube. Length of the tube is this plus this. It's mod of V naught plus mod of UV. That's a V naught is equal to F naught. That's the length of it. Just please note it down. Note down the calculation. Then we'll do the last case when your final image is added. Tell me once you have written, I'll scroll.
Done, sir.
Okay. The derivation for the case when your final image is at infinity is straightforward, just 2 steps and over. Yes, written. Let's do the last derivation. You can take screenshot of the last derivation if you want. So the last one, your final image is at infinity. So your islands is forming the final image. Your islands can form the final image at infinity only if the object of islands is at its focus. So this is the ray diagram. So what we do here is, see your object for the objective lens is at infinity. This is the image for the objective lens, which is A prime, B prime. We adjust the separation between objective and islands in such a way that the focus of objective and islands will coincide. So the focus of objective lens and the focus of islands would be at one place. So both will coincide. So when both coincide, so your A prime, B prime, which is the image for objective and object for islands, is at the focus of islands also. So if an object is placed at the focus of islands, then just like compound microscope, your islands will make final image at infinity. We're using same derivation. The only difference is O2 prime is not UE, it's Fe. It's just like compound microscope also. When we do this case of compound microscope, when your final image is at infinity, your object distance was not UE, that was minus of F. So the same thing here. So magnification comes out to be minus of F naught. That's it. So that is the magnification of your telescope when your final image is at infinity. This is known as novel adjustment. And NCRT have discussed this case in detail. And by default, if you have a telescope, then your if the question says a telescope and calculate the magnification, nothing is given. That means by default, it's a normal adjustment. Your final image is at. Please note it down.
Sir, can you scroll up, please? Yes, sir, done.
Tell me once you have written, I'll scroll it further. Can I scroll it now? Okay, if you want, you can take screenshot. Huh? You can take screenshot of this ray diagram. Then you can take screenshot of this calculation also. That's it. The same derivation, instead of UE, you will just write FE. And that's it. And I'm sharing the assignment of this optical instrument also. If you anyone have solved the previous assignment and want to discuss, I'm available. Just give me 1 second. I'm sharing the assignment. Okay. Okay, I'll share in a while. I don't have it. Okay, I'll share the assignment of optical instrument also. Okay, so let's stop here if you have taken the screenshot. Everyone have taken the screenshot?
Yes, sir.
Okay, so if you have any doubt, I can discuss. Otherwise, class is over. The next class most probably will finish this chapter. So the finishing this chapter means major portion of the syllabus is over. I will need just 3-4 more lectures to wind up the syllabus. If you have doubts, I can discuss. Otherwise, class is over. Thank you. Bye.
Thank you, sir.